To the Curious Calculator. In today's episode, we're going to be going over determining independence from two-way tables. All right, let's get started here. So we can see that on the left-hand side, I have the traditional two-way table. And then on the right side, I've represented the same information with a Venn diagram. So let's go through these and how we can interpret them and determine independence. So let's imagine that we did a survey where we went around and we surveyed people from two different cities, city X and city Y, and we asked them whether they drink coffee or not. And so we can see here that, for example, 55 people from city X said yes, they do drink coffee. 45 people from city X said no, they do not drink coffee. 42 people from city Y said yes, they do drink coffee. And 60 people from city Y said no, they do not drink coffee. And so when we're going to determine the independence here, let's say we want to determine whether living in city X and drinking coffee are independent or dependent. In order to find that out, what we want to do is we want to check if the probability of A, which would be living in city X, is equal to the probability of A given B, which we will say is drinking coffee. And so I'll say that right here. So A is going to correspond to living in city X, and B is going to correspond to yes, drinking coffee. So let's go ahead and calculate those probabilities. So P of A, the probability of living in city X, is going to be the total amount of people from the survey that lived in city X. And let's see, so we have 55 plus 45 over the total amount of people surveyed. And so that's going to be 55 plus 45. Whoops, that doesn't really look like a 4 there. All right, 45 plus 42 plus 60, which is going to be, let's see, 100 over 202. And when we calculate that, so 100 divided by 202 comes out to approximately, let's see here, 0.495. Okay, so that's going to be the probability of living in city X. Now let's calculate the probability of living in city X given that you do drink coffee. So P of A given B. We can calculate that by looking over here. So what's the probability of living in city X given that you drink coffee? So we're looking at this column right here. And let's see, so 55 people live in city X, so it's going to be 55 divided by the amount of people that said yes to coffee, which is going to be 55 plus 42. And that will equal 55 over 97, which comes out to approximately 0.567. And so from this, we can see that P of A does not equal P of A given B, and therefore the events A and B are dependent. So they are not independent. Okay, now I want to look over here at the Venn diagram and see how we can interpret this and determine if living in city A and yes, drinking coffee are independent. So on the left hand side here, where we see city X, this circle on the left, we can see that the amount of people from city X in the survey was 45 plus 55, which we also see that here, where in city X we have the 55 and 45. The amount of people that drank coffee is 55 plus 42, which we see here, yes, 55 and 42. And then the amount of people that both live in city X and do drink coffee is 55, which we see right here in the two-way table. So yes, coffee and city X, 55. So that's going to be in the intersection right here. And then the amount of people from the survey that neither live in city X nor drink coffee is 60, which we can see in this spot right here, where it's no coffee and they live in city Y. And in order to calculate whether city X is dependent or independent from drinking coffee, then we're going to do the same thing that we did over here, where we're going to see if the probability of living in city X is equal to the probability of living in city X given that you do drink coffee. And so let's see here. The probability, looking at this one, so P of A, probability of living in city X, is equal to 45 plus 55 over the total amount of people, which is the 45 plus 55 plus 42 plus the 60. So 45 plus 55 plus 42 plus 60. And this we can notice is exactly what we had when we were over here. It's the 55 plus 45 over 55 plus 45 plus 42 plus 60. So we know that this is going to come out to approximately 0.495. And then now we want to do the probability of living in city X given, let me change that. City X given that you drink coffee. And that's going to be, well, if you live in city X and you drink coffee, let's see, there's 55 here. So living in city X and drinking coffee over the total amount that drink coffee, 55 plus 42. And that we can notice is the same thing we had over here. And we know that that's going to come out to approximately 0.567. So again, we can see that because these two are not equal, they are dependent. All right, so now let's go over an example that's slightly different. We're going to imagine the same scenario. So we went around, we did a survey. We had some people from city C, some people from city D, and we were asking them whether they drink coffee or not. So let's see here. Now, to determine whether living in city C is independent of drinking coffee, we're going to calculate the same thing we did in the previous one. So we want to see if the probability of living in city C is equal to the probability of living in city C given that you drink coffee. So I'm going to say A is city C and B is, let's see, coffee. Yes. Okay, so the probability of A is going to be, what's the probability of living in city C? Well, it's 48 plus 72 over the total amount of people surveyed, 48 plus 72 plus 42 plus 63. And this equals, let's see here, 120 over 225. And that comes out to approximately 0.53. Okay, so we found the probability of living in city C. Now let's find the probability of living in city C given that you drink coffee. So that is going to be this 48 here, where you live in city C and you drink coffee, over the total amount of people that said they do drink coffee. So we're going to have 48 over 48 plus 42, which is 48 over let's see, 48 plus 42. 48. I'm like, let's see, 48 plus 42, 90. Okay. All right, so we have that, and then that's going to come out to approximately 0.53. All right, awesome. So we can notice here that P of A equals P of A given B. And therefore, living in city C and drinking coffee are independent events. So independent events. Awesome. All right, so now let's see this one represented as a Venn diagram. Again, we can see that the number of people that live in city C is 72 plus 48. The number of people that drink coffee is 48 plus 42. The number of people that both live in city C and drink coffee is 48. And then the number of people that neither live in city C nor drink coffee is 63. And so, in order to calculate or determine whether living in city C is independent of drinking coffee, we do the same thing. So, we want to find the probability of living in city C, which again is going to be that 48 plus 72, 48 plus 72 over the total amount of people surveyed. So 72 plus 48 plus 42 plus 63. And we know from up here, which we had the same thing here, that's going to come out to approximately 0.53. And then the probability of a given B is going to be, well, there's 48 people here that live in city C and drink coffee. And then the total amount of people that drink coffee is 48 plus 42, which we can see is the same thing as right here. So we know that's going to come out to approximately 0.53. And therefore, because these are equal, we can see that again, living in city C and the event drinking coffee are independent events. And that's going to be the end of today's video. I would just like to end with a little fun fact from philosophy. Did you know that in philosophy, an empiricist is someone who believes or argues that all knowledge comes from experience? This means that no knowledge is or comes purely from the mind itself, but is rather derived from our experience with the world.